Chinese robots have quietly taken control of the moon, not in a dramatic science fiction sense but in a much more impressive and real way. For years now, these robotic explorers have been up there, navigating mysterious lunar landscapes that humans have barely touched. They've been digging, scanning, analyzing, and gathering crucial data from regions previously left untouched. Most importantly, they've been collecting samples, rock, dust, and soil, some of which have made the journey back to Earth. And in those samples, Chinese scientists have found something new, something astonishing. A discovery that could reshape how we see the moon, and even change the future of life on Earth. The strange thing about the moon is that the more we learn, the more confusing and mysterious it seems. Earth itself is already a weird place, not just because of all the life it supports, but also because of the way it behaves compared to other rocky planets in the solar system. A lot of that weirdness comes down to our gray, cratered companion in the sky, the moon. When you start comparing Earth to other planets like Venus or Mars, the moon suddenly becomes a giant anomaly. It's far larger than you'd expect, especially for a planet our size. And that alone raises massive questions. Venus is the closest in structure and size to Earth, nearly identical in diameter and mass. Yet, despite all those similarities, Venus doesn't have a moon at all. Mars, which is a smaller rocky planet, does have moons, 2 of them in fact, but they're tiny. The biggest one is only about 22 kilometers across, and the smaller one is barely 12 kilometers wide. To put that into perspective, both of Mars's moons could fit inside the city of Chicago. And when you compare this to Earth's moon, which is over 3,400 kilometers wide, the difference is staggering. It's like our moon doesn't belong here. Things get even weirder when you look at the gas giants. Planets like Jupiter and Saturn have massive systems of moons, but those planets are hundreds of times larger than Earth. For instance, Jupiter is 318 times the mass of Earth, and yet many of its moons are about the same size as ours. That's completely unexpected. Our moon seems far too large for its host planet, and scientists have struggled to explain this oddity. It's a mystery that still doesn't have a perfect answer. And that's one of the main reasons we continue to study the moon, to understand why Earth ended up in such a unique situation. Back in the 1960s and 70s, when NASA sent astronauts to the moon during the Apollo missions, they returned with loads of lunar rock and dust. And almost immediately, scientists noticed something strange. Many of those rocks were shockingly similar to rocks found here on Earth. That wasn't supposed to happen. If the Earth and the moon had formed separately, as 2 individual objects in space, then their compositions should be very different. But that's not what the evidence showed. Instead, the data hinted at a much deeper connection between Earth and the moon, as if they were more like siblings born from the same cosmic event. This led to a groundbreaking theory, that the moon was once part of Earth itself. According to what we now call the giant impact hypothesis, sometime around 4.5 billion years ago, a Mars-sized rogue planet slammed into the young Earth. The collision was unimaginably violent, melting both planets and sending a massive amount of material into space. Most of that rogue planet was absorbed into Earth, sinking down and becoming part of our planet's core. Meanwhile, a huge chunk of Earth's outer layers was ejected into orbit, and that debris slowly came together to form the moon. It's a theory known as the Big Splash. This dramatic scenario explains why the Earth and moon are made of such similar material. In recent years, scientists have used supercomputers to simulate this kind of impact. They've run millions of simulations, and one of them matched everything we know about the Earth-Moon system almost perfectly. It's not a definitive answer, but it's the most convincing model we have. Still, it's just a theory, and that's why further exploration and research are so important. The more we uncover about how the moon formed, the more we can learn about how our own planet came to exist, and why it is the way it is today. Over the past 5 years, China's space program has been leading the charge in lunar research. With a massive investment of time, money, and resources, they've managed to land robotic spacecraft on the moon and conduct experiments that are answering questions scientists have asked for decades. One of their primary goals has been to study parts of the moon that we've never seen up close before, especially the far side. This region of the moon had remained untouched for all of human history until China made a bold move to change that. And what they found over there is nothing short of fascinating. Let's talk about this far side of the moon, the one we never see from Earth. Despite popular culture references like Pink Floyd's Dark Side of the Moon, or sci-fi movies like Transformers, the far side is not actually dark. It receives just as much sunlight as the side facing us. The only real difference is that it never rotates into view from Earth. Because of the moon's synchronous rotation, we only ever see one side. You'd expect both sides to be pretty similar, given they share the same origins. But they're not. The far side looks radically different, and scientists are still trying to understand why. Unlike the side of the moon we're familiar with, full of smooth, dark plains formed by ancient lava, the far side is much rougher. It's covered in bright gray rock, pitted with craters from countless asteroid impacts. There are hardly any of those lava-filled regions known as Maria that dominate the near side. This difference is a puzzle. Why would one side of the moon have so many volcanic features, while the other does not? China's Chang'e 4 mission was launched to help answer that question. In January 2019, it became the first spacecraft in history to successfully land on the far side of the moon. Chang'e 4 was China's second successful lunar landing, and this time, it deployed a rover called Yutu-2 or Jade Rabbit 2. This little rover began an exploration of one of the moon's most intriguing features, the von Karman crater. This enormous impact site is about 180 kilometers wide, roughly the length of the entire island of Cuba. But von Karman is just a small part of something even more extraordinary. It sits within the South Pole Aitken Basin, which is one of the largest and oldest impact craters in the entire solar system. This ancient scar on the moon stretches about 2,500 kilometers across, almost as wide as India. The South Pole Aitken Basin is particularly important to scientists because of what it reveals about the moon's deep interior. The asteroid that created this giant crater would have smashed through the moon's outer crust, digging possibly 13 kilometers deep and exposing material from the moon's mantle. That's the thick layer of rock beneath the surface crust, the place where some of the moon's biggest secrets are buried. The Apollo missions never brought back any mantle material. But Chang'e 4's Yutu-2 rover found something special in the von Karman crater, a type of rock that scientists now believe came directly from the lunar mantle. This was an incredible discovery. It marked the first time in history that humans had access to lunar mantle material. That rock, buried deep beneath the moon's surface for billions of years, was finally revealed thanks to China's robotic rover. It opened the door to an entirely new level of lunar science. Researchers back on Earth immediately became intrigued. What else might the far side be hiding? What other geological mysteries were waiting to be uncovered in these ancient, untouched regions? Yutu-2 had only just begun its journey, but it had already found something no one else ever had. And then things got even stranger. Later, in December 2021, the same Yutu-2 rover captured a very peculiar image. As it slowly rolled across the dusty terrain, it spotted something in the distance that didn't look natural. It appeared to be a cube-shaped object sitting on the horizon, a perfectly geometric structure standing out against the randomness of the lunar surface. The image caused a stir among scientists and internet users alike. Could this be something artificial? A monument? A remnant of an alien civilization? Some even jokingly compared it to the mysterious monolith from the movie 2001, A Space Odyssey. The speculation spread quickly, but the truth was less dramatic. For weeks, the discovery had everyone on edge, sparking wild theories and intense speculation. But as the data came in, it became clear that what we had seen was nothing more than a trick, a mix of light, shadow, and the limitations of digital cameras. Because of their square pixels, low-resolution images can make anything appear square-shaped until you zoom in enough to see the real contours. Still, the incident led to something major, a renewed mission to the moon's far side in 2024. This time, China's Chang'e 6 lander returned to the South Pole Basin, not just to explore, but to bring back actual samples for the first time in history. These samples marked the first-ever material collected from the far side of the moon and delivered into human hands. What Chinese scientists uncovered was a type of rock that looked and felt completely different from what the American Apollo astronauts had brought back decades ago. Those U.S. missions collected plenty of lunar rock and dust, but it all came from the moon's near side, primarily around the equator. Back then we thought we had a good understanding of the moon's makeup. But the truth is we were only seeing one side, literally. The far side's composition turned out to be full of surprises. The material from the far side wasn't just lighter in color, it had a completely different texture. The initial findings from Chinese researchers revealed that the dust and rocks were thicker and more adhesive. They weren't the loose powdery dust seen on earlier missions, but rather had more lumps and cohesion. Volcanic rock was also noticeably scarce compared to the near side. But when lava samples were found, they were surprisingly young. Scientists had assumed that the far side cooled faster due to the Earth's lingering heat during its early volcanic years, so they expected only ancient materials. But the reality was quite different. Among the fragments recovered by Chang'e 6 was a piece of lava estimated to be 4.2 billion years old, making it the oldest known lunar rock ever found. But even more intriguing was the discovery of relatively young volcanic rocks averaging about 2.8 billion years. This is younger than many of the samples brought back by Apollo missions, which were often over 3 billion years old. This suggests that the Moon, especially the far side, remained hot and geologically active much longer than previously believed. That finding directly challenges aspects of the widely accepted giant impact hypothesis, also known as the Big Splash theory. If Earth and the Moon did form simultaneously after a massive impact, then the much smaller Moon should have cooled and solidified more quickly. Especially the far side, being farther from Earth's heat, should have been cold and dead early on. But the presence of younger volcanic rock suggests that didn't happen. The far side might have remained active for far longer, meaning there's still a lot we don't understand about the Moon's formation and thermal evolution. And this brings attention back to the near side, where the bulk of our Moon knowledge still originates from Apollo-era exploration. Those American landings were limited by design. The astronauts could only land on broad, flat plains near the equator, areas chosen for safety rather than scientific curiosity. Even with the advantage of lunar rovers, the total distance covered across all Apollo missions was just around 25 kilometers. To put that in perspective, that's less than a fifth the size of Disney World. Imagine an alien landing on Earth, walking around one amusement park, and thinking they understood the whole planet. That's basically what we've been doing with the Moon. But now, Chinese missions are starting to expand our understanding in major ways. The Chang'e 5 mission, for instance, was the first lunar sample return in over 4 decades, since the 1970s. Because it was robotic and didn't need to prioritize